Okay, everyone. So we're finally to a hard problem. This is our last example for this section, and so far you've probably been like, "This is easy. How hard could it get?" Well, this still isn't terrible, but it's a lot harder than our previous things, just because there's a lot more going on. First off, you see we have this kind of crazy pipe configuration here, and you got to figure out the position vector for it. Um, Once again, it's not actually terrible, it just looks bad. So make sure you take some time, do that correctly. Second thing is our force vector isn't given to us as nicely. Okay, well this is a 3D force vector. I'm going to have to break it up into its components. So make sure you do that correctly. Taking into account direction, it's pointing down. That's going to be negative. So the z direction, z component's going to be negative. Little heads up. Now, with that in mind, I want you to try it. You know what to do. Find the force, find the position vector, and then take the cross product. So really the whole problem here is going to be this. This step is the same every single time. This changes depending on your problem. So with that in mind, take a few minutes, try it out, and see how it goes. So 3, 2, 1, you're back. Let's actually look at this and see how it looks. So first off, we got to get those position vectors and the force vectors. Now, this problem gets done like lightning when we're doing a PowerPoint, so let's take some time and actually think about it. First off, this is in meters, so that's why the numbers have changed from 400s to 0.55. And let's look at it. We see it goes 400 millimeters in the x direction, okay? And that looks pretty fine. And then we go 300 millimeters, sorry, goodness, 400 millimeters in the y direction. Then we go 300 millimeters in the x, and then another 250 millimeters in the x. Okay, so that's where the 0.55 comes from, 300 plus 250, 550, and switch to meters. That's where the 0.4 comes from. And we see that the only time it moves down in the z direction is right here. So that's negative 0.2. Okay, so that's not too terrible. It's just, gotta be a little bit careful because they decide to bend the pipe and to make it a little bit harder on you. It's a good thing. Second thing, right here, a little bit more crazy. We've got a lot going on. So first off, we realize we need to calculate this f prime vector that is right here. I'm going to use that arrow since I have it already drawn. The f prime vector, which is right there. And we also need to calculate the fz component. So let's turn this sideways. Look something like this. And calculate those components. So right here I have f prime. This is f, and this is fz. We have an angle of 30 degrees. Now, easily you see that fz is the opposite side, and so that's why it's negative 80 sine of 30 right here. And f prime is going to be the adjacent side, so it's going to be cosine of 30. So you can see that appearing in our I and j components. Now, once we've calculated f prime, which is 80 cosine of 30, we have to calculate the x and the y components. We draw a second triangle. So right here we have our y component. So be careful I write it down correctly. Our x component, and then our f prime component with an angle of 40 degrees. Be very careful that you write the components correctly. This one on the side, even though I'm writing it up and down, that's the x component here. This one on the top, even though it's left to right, it's the y component. You can redraw this any way you want to work better with your brain, but just be very careful about that. Make sure you're drawing it as it's shown in the picture. Now, we already know that f prime is 80 cosine of 30. Fy happens to be the adjacent side, so that would be multiplying 80 cosine of 30 times cosine of 40. And you see that right here. There's that cosine of 40. And fx would be the opposite. It's the opposite side over hypotenuse, which is sine. And so you see that that's sine of 40 there. So all this makes sense. We've done this a bunch of times in the past on previous examples. This isn't really a big jump. Either way, you still need to make sure you're practicing it. Make sure you go through these examples, and if you really still feel like you haven't mastered it, do some book problems. I'll say that people who do best in this class are the ones who do extra book problems. Just start at the beginning of the chapter, work to the end. And you'll probably find these problems that you're seeing in the examples and homework examples all in there. So push yourself. Let me clear off my screen so we can actually see all of the numbers, and we'll go on to the next step. finally, we find the moment by using the cross product, which you get right here. And this is our moment vector, which we didn't work out the steps, but like always, we cover something. I cover the I component, and I do these two. And that gives me my I component. I cover the J, and I do the I. I'm getting way too many lines, so I'm going to go ahead and erase it again. And I cover the K, and I do these components. Whichever one I cover, that's the component I'm solving for at that time. And we have our answer. As long as we've done it correctly, this would be clockwise, right? Counterclockwise. And we're done. That's the problem. So as you can see, the biggest, hardest part was something we've done in previous sections, which is just breaking the force up into its components. The only other thing that would be kind of difficult is that our position vector wasn't quite so straightforward, and you might have missed either the drop or this jump. So in both cases, make sure you're very careful with your steps, and you should get the answer correctly. Well, I hope this helped you, and I'll see you all next time as we continue through Chapter 4. Bye-bye.